This is Chapter 6, Lesson 5, all about a rhombus, or multiple rhombuses, or rhombi, not rhombuses, and also squares. So we just previously went over rectangles, and now we're going over the characteristics of we're going to start with a rhombi and then go over a rhombus and then go over squares. So basically a rhombus is a parallelogram, has all the properties of a parallelogram, plus the diagonals are perpendicular. So here is a rhombus. It basically looks like a square. It's got 4 congruent sides, but it was like blown over a little bit, right? It's like tilted a little bit, like a parallelogram, okay? So this is a rhombus. The diagonals bisect each other and they form 90-degree angles everywhere. They are perpendicular, and also each diagonal bisects opposite angles. Okay, so we haven't really talked about that in any of our parallelograms yet because it hasn't been true yet. But for a rhombus, this diagonal bisects the angles here, right? So if this top part here was 30 degrees, this bottom part would also be 30 degrees. This diagonal cuts this whole entire corner in half. Same with this here. This diagonal cuts this corner and this corner, cuts each of those in half, right? So opposite angles are congruent, and then the diagonals that connect them cut them in half. They are angle bisectors. That's true for a rhombus. So diagonals are perpendicular and opposite angles are cut in half. For a square is kind of interesting because we all know what a square is, right? It's a 4-sided shape that has equal length sides and 4 90-degree angles. It basically has all of the characteristics of a rectangle and a rhombus, right? So all the characteristics of a parallelogram, plus, remember, rectangles have 4 90-degree angles and have equal length diagonals. And then a rhombus has perpendicular diagonals. They intersect at 90 degrees. So each of these angles is 90. This guy, all of these angles in here are 90. And also, they bisect opposite angles. And if each angle is 90 degrees and each angle gets cut in half, each of these angles is 45 degrees, right? So all these little corners of each triangle here, split up by the diagonals, are all 45 degrees. That's a square. So a square is pretty interesting. It's got lots and lots of rules, lots of attributes, and it is a parallelogram with all of the characteristics of both a rectangle and a rhombus. It's both, okay? So let's use that to kind of go over some examples. The book or the worksheet here has written out one example for you. So an example in the rhombus ABCD, BAC is 32, it's labeled here. Find the measure of each numbered angle. So we've got to find 1, 2, 3, and 4, and we might not be able to find it in that order. I'm going to try and zoom in a little bit. There we go. Okay, so we know this is a rhombus. It tells us it's a rhombus. And we just said that in a rhombus, the diagonals bisect each other at 90 degrees. So we know the measure of angle 4 is 90 degrees. So we can write that down first. Measure of angle 4 equals 90. I wrote that over here. Okay, so if I know that this angle's 90 and this one's 32, well, this is a triangle, so I know all 3 add up to 180, right? So 90 and 32 is 122. And 122 subtracted from 180 gives us 58 degrees. So angle 1 here has to be 58 degrees. So I wrote down measure of angle 4. Measure of angle 1 equals 58. Okay, and then I know that angle 2 also has to be 58 because remember in a rhombus, a diagonal cuts the corner in half. So if this half is 58, that means this half has to be 58 as well. So the measure of angle 2 equals 58. And so lastly, I need to find the measure of angle 3 right here. The measure of angle 3 is what? Well, remember, this is a parallelogram before it's a rhombus, right? A rhombus has all the characteristics of a parallelogram plus perpendicular diagonals and angle bisectors from the diagonals, okay? Which means these opposite sides are parallel and they are cut by the diagonal transversals, right? So if that's the case, then this 32-degree angle right here and this angle 3 right here are alternate interior angles. Then we got these two parallel lines cut by this guy. So this 32-degree angle is this one here. This angle 3 is this one here. Alternate interior angles are congruent when your lines are parallel, right? Which our lines are. This angle and this angle cut by this transversal are alternate interior. So if this one is 32, angle 3 has to be 32. So I'm going to write that here. Measure of angle 3 has to equal 32 degrees. So we're just kind of taking what we know about a rhombus, if it tells us it's a rhombus, and applying it. That's it. All right, so let's back up a little bit and start doing some problems down here. All right, all of these problems, I believe, refer to the shape here at the top. So hopefully that stays in view. Okay. Quadrilateral ABCD is a rhombus. Do I have my... I don't know. Oh, there it is. My highlighter. I tell y'all in like almost every video, I'm a visual learner, so I got to highlight stuff and draw on stuff. All right. This is a rhombus. We know that for a fact. It tells us that. So all of the characteristics of a rhombus apply. Find each value or measure. So number one, if the measure of angle ABD, this little guy, is 60 degrees, find BDC. BDC. Well, this angle and this angle are alternate interior, right? And we know the opposite sides are parallel because it's a parallelogram if it's a rhombus. So if this angle is 60 degrees, this one has to be 60 as well. So we're just going to say 60 degrees, alternate interior angles. No math involved. Number two, AE, this guy right here, equals 8. Find AC. Well, we know a diagonal is bisected, right? That's in any parallelogram. So if this is half my diagonal and it's 8, what's the entire diagonal? 8 and 8, which is 16. So AC equals 16. If half of it's 8, then the whole thing has to be double 8, right? All right, number 3. If AB is 26, this line here is 26, and BD, this diagonal, is 20. Find AE, this guy. All right, so if this, we're looking at basically this triangle, right? AB is 26, this guy here. BD, this whole entire diagonal is 20, so half of that is just this little top part here, BE, and half of 20 is 10. Find AE, which is this side. So this is the side I don't know, right? And I know that this is a right triangle because it is a rhombus, right? And these diagonals are perpendicular. So I know this is a 90-degree angle, even though I didn't draw it like it looks like a 90. So I can use Pythagorean Theorem. So x squared plus 10 squared is going to equal 26 squared. X squared plus 100 equals, I don't know what 26 squared is, get my calculator. I feel like sometimes math teachers should just know any problem, and I don't. 676. All right, and then we're going to subtract 100. I need to go to my little extra paper here. Subtract 100 from both sides, so x squared equals 576. And then I need to just figure out what x is. I don't want to know what the side squared is. I just want to know what the side is, right? So I'm going to take the square root of 576 is 24. Look at that. It worked out. Oh, my dog's barking. So the missing side, AE, equals 24. Hopefully you guys will have more room on your paper to show all your work. And make sure you are showing all your work. All right, find the measure of CEB. CEB. Okay, so I know this is 90 because these are perpendicular. So the measure of angle CEB equals 90. Number 5. Find the measure of if the measure of CBD is 58, find ACB. CBD, this guy, is 58 degrees. Find ACB. ACB, this angle, right? Well, sometimes we want to say, well, this looks like it has to be isosceles, so both of these have to be equal. Not true in a rhombus. In a square, that might be true, but not true in a rhombus, okay? So here, this angle is 58. We know this one in the middle here is 90. We already did this up top. 90 plus 58 is 148, right? So what does this one have to be? If these two add up to 148, this one has to be, what, 32? 32 degrees. So the measure of angle ACB equals 180 minus 148, which equals 32 degrees. Oh, sorry, I didn't know you can see that. All right, number 6, if AE is 3x minus 1, AE is just from here to the middle, is 3x minus 1, and AC, the entire thing, is 16. Find x. Well, 2 of these AEs equals the whole thing, AC, right? Because AE is half, so that means EC is the same size. So 2 of these, 3x minus 1 are equal to 1 entire AC. So 6x minus 2 equals 16. Add 2 to both sides. 6x equals 18. And then divide by 6. So x is going to equal 3. And it told us to find x, so we did. Almost done. Number 7, if the measure of CBD is 6y and ACB is 2y plus 10, find y. CDB is this guy here, and that is 6y. ACB is this guy. Find y. CDB, CDB, this guy. This is 90, this is 6y. And this guy is the same size. Okay, so 90 plus 6y plus 2y plus 10 equals 180. Because that's all 3 angles, right? This angle here it's saying is 6y. This angle up top it's saying is 2y plus 10. But remember this angle bisector here cuts these in half. So if this one's 2y plus 10, this angle has to be 2y plus 10 as well, this bottom one. And I know this guy is 90. So 90 plus 6y plus 2y plus 10 equals 180. So now I can combine like terms and solve. 6y, 2y is 8y, plus 90 and 10 is 100. Minus 100 on both sides, divide by 8, and y equals 10. And you can do that on your own. I'm running out of space here. I guess I had all that. Could have kept one. All right, number 8. I'm still looking at this picture up here that I've drawn all over. I'm scrolling down. If AD is 2x plus 4 and CD is 4x minus 4, all right, what do AD and CD have to do with each other? AD and CD. Okay, so in a rhombus, all 4 sides are congruent. Not the diagonals, but the sides are the same length. So I'm going to set these equal to each other. 2x plus 4 equals 4x minus 4. Get rid of my smallest x. 4 equals 2x minus 4. I'm trying to get x alone. 8 equals 2x. Divide both sides by 2. So x is going to equal 4. And you can always plug it back in and try it. 2 times 4 is 8, plus 4 is 12. 4 times 4 is 16, minus 4 is 12. So that works. Let me know if you guys have questions, and look out for video number 2.